Okay, what we are doing today is in your groups of 3 or 4, you're going to discuss those 7 problems. Notice we have 7 groups. So at the end of about 15 minutes, you guys will present your problem, okay? And then the key is you're going to record it on the iPad. So what you're going to do is make sure that you, when you do your problem, if you look at somebody else's paper or in your group, pick whose problem looks the best and can be explained the best. And if you don't like any of them, redo it so I can see the picture of it. I'm basically going to walk by, take a picture of it, and you can pick anybody in your group today to present. Okay?
Number 4. The figure shows a bridge arching over the Laconic Parkway to accommodate the road beneath. The arch is 100 feet wide at its base, 20 feet high in the center, and parabolic in shape. So A. The arc can be described by y equals kx times x minus 100. If the origin is placed at the left end of the arch, find the value of the coefficient k that makes the equation fit the arch. So the length is 100, and then the height is 20, and then it's halfway, which is 50. So the equation y equals kx times x minus 100, you plug in the points, which is 20 in the place of y and 50 in the place of x, and then you solve for these, which is negative 50, and then you multiply them together, which should be negative 2500, and then you just divide, and then you get either 0.008 or negative 0.008 or negative 1 over 125.
Is it possible to move a rectangular object that is 40 feet wide and 16.5 feet wide, a wide trailer, for example, through the opening? Explain. Well, first, we knew that this point right here is 100, and then this point right here is 0. The trailer's width is 40, so we subtracted 40 from 100, which is 60. Since the trailer is going to be going through the middle, you have to divide that by 2, which gives you 30. Now that you have that, you're going to plug it into the equation that you came up with in the beginning and plug it in for x. So now you have y equals negative 0.008 times 30 multiplied by 30 minus 100, which leaves you with negative 70 times negative 0.24, and when multiplied, y equals 16.8. Since 16.8 is greater than 16.5, the height for the trailer, yes, it can fit.
There is a unique parabola whose symmetry axis is parallel to the y-axis, and that passes through 3 points. 1, 1, negative 2, negative 2, and 0, negative 4. Write an equation for it. Given any 3 points, must there be a parabola that will pass through them? Explain. Alright, so what we did originally was we took the 3 points, 1, 1, negative 2, and 0, negative 4, and you can just see from the 3 points that are existing that since 0 for C, since the 0 is meant for the x, then the negative 4 is already the y-intercept, so negative 4 is for C. And then we plugged in negative 1 into y equals ax squared plus bx plus c, getting negative 1 equals a times 1 squared plus b times 1 minus 4. And then once you get all that down, you get 1 equals a plus b minus 4. And then we added 4 to the other side, we added 4 to the other side, and got 3 equals a plus b, which then factored down to b equals 3. And then on the other side, we just pretty much did the same thing, plugged negative 2 into the same equation, y equals ax squared plus bx plus c. Factored everything down, equated everything, and got 4a minus 2b equals 2. And then you can plug b, which equals 3, into that, and get 2a plus 2b equals 10. And then factor that down to, once you plug b into that, you get 6a equals 12 and a equals 2. And then you plug b, a, and c back into the equation to get 2x squared plus 3x minus 4.
Okay, he kind of lost track of his work here, so I wanted to show that the order was a little bit backwards. The first thing we need to do is right here, come up with this equation, which is fine. And then you also have this equation. This should be a plus b equals 5. Okay, then what happened is this, we use elimination right here. So instead of a plus b equals 5, we multiplied it by 2 to get 2a plus 2b equals 10. And that is what helped us find a first. So we just eliminate it down. 4a plus 2a is 6a. Negative 2b and 2b, they cancel to 0, add to 0. 2 plus 10 is 12. Found a, and then put the a back in there.
So for the first part, you have to get like common denominator for the fractions. So you multiply the left one by x over x, and then the right one by 3 over 3, so that you get 3x on the bottom, as seen here. And so then, of course, the top gets multiplied too. So that gives you that, and then you can add them together. And then we multiplied by 3x on both sides to cancel out the bottom 3x. So then we got this, and then we subtracted the 6x so that it's 0 on the other side so that we could factor it out. And we factored it to x minus 3 times x plus 1. And we got x equals 3 and x equals negative 1.
What is the distance from point 4, 2 to the point negative 3, negative 2? Be prepared to explain your method. So first I plotted the points on a graph. So that's 4, 2, and this is negative 3, negative 2. And then I found the distance in between them, and it was 7 and 4, and then I did the Pythagorean theorem right here, and I got 49 plus 16 equals 65, and then I did the square root of it, and I got 8.06.
Another way you could do it is through the distance formula, which is what I did right here. And I just, I had 4, 2 as one point, and I had negative 3, negative 2 as my other point, and just put them in. So I had 4 minus negative 3 squared plus 2 minus negative 2 squared. And I got up with the square root of, all that was under square root. And I got with the square root of 7 squared plus 4, and which equals the square root of 49 plus 16, which is the square root of 65, which is 8.06. To solve this, I put it into a squared.
Read the problem first.
Alright, to get from one corner of a rectangular court to the diagonally opposite corner by walking along two sides, a distance of 160 meters must be covered. By going diagonally across the court, 40 meters are saved. Find the dimensions of the court to the nearest centimeter.
Awesome.
Here's the picture I drew. To solve this, I put it into a squared plus b squared equals c squared. And to start, we FOILed 160 times 160, and 160 times negative x times 160, and negative x times negative x. Then we solved x squared and 120 squared. We got 25,600 minus negative 160x minus 160x plus x squared equals 14,400. To plug this into a calculator, I added 11,200 to the left side. After plugging it into the calculator, I also plugged in y equals 0 for the intersects.
after this, I went to second calc and found the points of intersection
Point to them on the picture.
here and here.
Okay.
And then I checked my answer by doing the square root of x squared plus x squared.
A mathematics teacher wants to make up a quadratic equation ax squared plus bx plus c equals 0, so that a, b, and c are integers, and the correct solutions are x equals 1/2 and x equals -3. Find values for a, b, and c that will do the job. Is there any more than one equation that will work? So how I did this was I just wrote down the quadratic formula, and then you can instantly plug the numbers right there into, is that standard form? Or something.
Factors.
Into two factors. Then when you FOIL, you get your form all filled out, and then you instantly have your answer right there.
Simplified everything by 2 there to simplify.